Hello everyone, welcome back to Math was by Vishal. So in the previous video, we have seen the part 1 of top 10 PYQs from the chapter 3D geometry, right? Now in this video, we'll see the part 2 of top 10 PYQs from the chapter 3D geometry. Now in this video, I'll be taking 5 questions which are frequently asked in JEE mains. So let's try to concentrate here. Okay. So let's see the first question for today. And this was a question from JEE mains 2025. And let's say the question, let L1, L2 are two lines, then which of the following points lies on the line of shortest distance between L1 and also L2? Now, this is a bit lengthy question because when the question is like asking shortest distance between two lines, then it is direct formula is there. You can do it without any problem. But here, this is a question where you have to find out the line of shortest distance. So we have some standard methods for this one. So let's try to see the method. First thing, let's take care of diagram just to be clear. Let's say this is line L1 and let's say this is line L2 here. Now, what is the thing that we know about line of shortest distance? It will be perpendicular to both the lines L1 and also L2 here, right? So let's mark it like this and let's call this as the line of shortest distance. Okay. And then I will take it as some line L. Okay. Now I'll assume that this line L is meeting line L1 at point A and then line L2 at some point B in this way. Now, the first thing you're supposed to do is assume the points A and B on L1 and L2 respectively. But we know very well how to assume the points, right? So I will take the first line is equal to some K1 so that I will get the general point on L1, that is point A, as nothing but, you know how to do this one, right? 2K1 plus 1, comma, 3K1 plus 2, comma, 4K1 plus 3. Similarly, we'll try to take this second line is equals to some K2 and then I'll try to assume the general point on this one, that is point B, which is clearly 3K2 plus 2, comma, 4K2 plus 4, comma, 5K2 plus 5. So these are the 2 points A and B which are lying on L1 and L2 respectively, and more importantly, they are lying on the line L. Now here, my idea is to find out the DRs of line AB, DRs of the line AB. But we know very well how to calculate the DRs of line joining 2 points, right? We simply subtract the coordinates, right? So let's try to subtract and see what we get. So DRs of AB are nothing but 3K2 minus 2K1 plus 1, comma. Similarly, 4K2 minus 3K1 plus 2, comma. This will be 5K2 minus 4K1 plus 2. So we have got the DRs of the line AB. But now the next part is very important here. As you can see, this line L, which is the line of shortest distance, is the line which is perpendicular to the two lines L1 and L2. And in the previous video also, I have solved 2 questions based on this. Whenever a line is perpendicular to two given lines, you can find out the DRs of that by simply taking the cross product of the two parallel vectors, right? So what I can do is I can directly write down the DRs of the first line. So DRs of the first line are 2, comma 3, comma 4, and then DRs of second line are 3, comma 4, comma 5, which are simply the denominators of the straight line in the standard form. Now let's try to find out the DRs of the same line L, DRs of the line L using cross product concept, that is det of I J, K, and the line L1 has the DRs 2, 3, 4, and the second one has 3, 4, 5. And if you expand this properly, you'll be getting I cap multiplied by 15 minus 16, which is minus 1, minus J cap multiplied by 10 minus of 12, which is minus 2, and then plus K cap multiplied by 10 minus of 12, which is again minus 2. Okay. So k cap multiplied by it should be 8 minus of 9, that is minus 1. And finally you get minus I cap plus 2j cap minus of k cap. So from here we can conclude that the DRs of line L are nothing but the coefficients of ijk here, that is minus 1, 2, comma minus 1. Okay. Now, the main thing you have to notice here is if you take this as the DRs of the line AB, let's say 1, and then let's say this is DRs of the line L. But what is the observation here? The line AB is nothing but the line L, which means we are writing the DRs of the same line two times. So they have to be in the same proportion, right? So let's try to equate the ratios, corresponding ratios here from 1 and if you equate the ratios, we get an equation something like this, right? 3k2 minus 2k1 plus 1 whole divided by minus 1. This should be is equals to again 4k2 minus 3k1 plus 2 whole divided by 2 is equals to similarly 5k2 minus 4k1 plus 2 whole divided by minus 1. Now, clearly, you know how to solve this equation, right? Clearly, you can equate these two here. You'll get one equation in terms of k1 and k2. Equate these two here, and you'll be getting one more equation in terms of k1 and k2. And now your idea is to solve these two for the values of k1 comma k2. Okay, and once you know k1 comma k2, you can take those values of k1 comma k2 and substitute in the points a and b, right? Because you can see here we have assumed the points a and b, and when you solve these two equations you will get the values of k1 comma k2. Take those values of k1 comma k2 and substitute back in the points a and b. So once again I'm leaving the solving part for you. So if you solve those and substitute back, you will get the point A in this way. That is 5 by 3, comma 3, comma 13 divided by 3. Similarly, you will get point B also, which is 3 by 2, comma 10 by 3, comma 25 divided by 6. Okay. As I told, I'm leaving the solving part for you. Now we have got both the points A and B here. Now ultimately what we have to do in the question, check it. Which of the following points lies on the shortest distance line between the lines L1 and L2, which means first thing we have to construct the line L. So let's do that. We know how to write down the line L here, right? That is because line L DRs are already there, which is minus 1, 2, minus 1. And you can take any one point as reference point and you can construct the line equation. So let's say I'm taking the line equation by using the point A here. So let's write down x minus of 5 by 3 divided by minus 1 is equals to y minus 3 divided by 2 is equals to z minus 13 by 3 divided by minus 1. So you get the line equation here. Okay. So this is the standard method to find out the line of shortest distance. But as I told you, it's a lengthy question definitely. So you have to be very fast and accurate while solving this kind of questions that is based on line of shortest distance. And moreover, the problem is question is not over yet because we have to verify option by option. Okay. For example, if I want to verify for the option A, what you need to do is take the point A, which is given by, okay, I will do one option. You try to do the remaining. Option A is given by 14 by 3, comma, minus 3, comma, 22 divided by 3. So you know very well how to check whether a point is lying on this line or not. What you do is you simply take this point and substitute it here. So if you substitute, what you're going to get 14 by 3 minus of 5 by 3 divided by minus 1 is equals to minus 3 divided by 2 is equals to 22 by 3 minus of 13 divided by 3 divided minus 1. Now, if all these values turn out to be same, only then we can say that the point A will be lying on the straight line. Okay. Otherwise, we say that the point A does not lie on the line. So in this way, you have to check all the options one by one. Now it is your work to check whether this point A is I mean, the option A is satisfying or not. In the similar way, you try to check the options B, C, D also. Okay, but this is gold standard method to find out the line of shortest distance between two lines L1 and L2. Okay, let's take the second question, and this was a question from JEE Mains 2025. And once again, this is one of the frequently asked type in JEE Mains from 3D geometry. So let's try to see the proper method for this one. So let a line L pass through the point 1, comma 1, comma 1 and intersects the two given straight lines. And which of the following points lies on the line? Which means you have to find out the line L here. And we have different methods to solve this exact question. So I will tell the easiest method for you, which will be a standard one. First of all, let's take the given lines as L1 and also L2, right? Okay. And then I will try to assume the drs of the line L, because the only thing which we need to write down the equation of line L here is the drs of the line L. So let me assume the drs of line L as a comma b comma z. I'm mentioning that here. You can notice drs. Okay, this is our assumption. And when we know the drs and a point on the line, we know how to assume write down the line equation, right? So let's write down line L is x minus 1 divided by a is equals to y minus 1 divided by b is equals to z minus 1 divided by c. So this is your line L. Okay. Now they are saying that this line L here is intersecting both the straight lines L1 and L2. So let us take a rough diagram here and let this be the line L. Now we have different methods, and I think this is the easiest method to solve this question here. What we are going to do is we are going to use the concept of coplanarity. That is, whenever two lines are intersecting, definitely they have to be coplanar, right? And whenever two lines are coplanar, we have a standard property. I will mention that here. For coplanar lines, we have the standard property, that is det of x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, and then a2 b2 c2. This should be is equals to 0. And this is the property for two coplanar lines, or also we can say intersecting lines, because intersecting lines are always coplanar, right? And that is the thing that I'm going to do in this question, because here L1 and L are coplanar because they are intersecting. And now by looking at the line L1 and L, I'm going to use this property. So observe very carefully. So it will be det of x2 minus x1 will be 1 minus 1, which is 0. And y2 minus y1 will be 1 minus of minus 1, and then z2 minus z1 will be 1 minus 1. And then the drs of first line, that is 2, 3, 4, and drs of second line a, b, c. And this det value must be is equals to 0. Okay, so let's try to solve this one. And I'll write directly here, this is 0, and this is 2, and this is equals to 0. So let's expand. It will be 0 into 3c minus 4b, and then 2 times minus 2 times of 2c minus 4a, and then plus 0 times of 2b minus 3a, and which should be is equal to 0. Anyhow, this is 0, this is 0. You can cancel out the minus 2. You can cancel out the common factor 2 also, and finally you get one condition, that c is equals to 2a. Okay. And in the similar way, what I am going to do is the line L2 and the line L are also coplanar, because they are also intersecting. If they are intersecting, they must be definitely coplanar here. Okay. Now, by looking at the two lines L and L2, I'm going to write down the same formula here. So let's try to concentrate here, which is going to be determinant of 1 minus 3, and then 1 minus 4, and then 1 minus 0. And the drs of second line are L2 are 1, 2, 1, and the drs of line L are A, B, C. Okay. And now let's try to expand and get one more relation in terms of A, B, C. Let's see what we get. This is minus 2 times of 2C minus of B, and then plus 3 times of C minus A, and then plus 1 multiplied by b minus 2a is equals to 0. So let's expand. It is minus 4c plus 2b plus 3c minus 3a plus b minus 2a is equals to 0. So if you do the proper calculation here, you get minus c and plus 3b, and then minus 5a is equals to 0. But if you observe carefully, already we have got c is equals to 2a. I'll take that and substitute it here, from which you get 3b minus 7a is equals to 0. Or also I can write down b is equals to 7a divided by 3. Okay. Now we just need only two relations between a, b, and c, because we need the drs. So to find out drs, we just need the ratios, right? Because if you take the drs now, drs of the line L, if I take it as some a is to b is to c, and then a value here is a, But B value is what? 7a divided by 3, and whereas C value is 2a. And if I cancel out the common factor a and multiply by 3 here, I'm going to get it as 3 is to 7 is to 6. This implies now the DRs of the line L are nothing but 3 comma 7 comma 6. Now what is that? We have directly the DRs of the line L, and also it is passing through 1 1 1. And now let's construct the equation of line L, that is x minus 1 divided by 3 is equals to y minus 1 divided by 7 is equals to z minus 1 divided by 6. Z minus 1 divided by 6. So this is your line L. And once again, it is just like the previous question that we need to check which of these following options lies on the line L. Just now I told you, right, what to do if you have to verify whether the point is lying on the line or not. Take option by option. Take the first option, substitute in the line L here, and check whether it is satisfying or not. If it is satisfying if all the values are same, it is lying on it. Otherwise, it is not. Okay, so this is a standard and easier method to solve for the DRs of a line which is intersecting two given lines. Okay, very important. Right. Okay. Let's take the next question. Now, this was a question from J Mains 2024, and this is one of the interesting question and where many students got confused while solving this question because I'll tell you what is the reason. Look at the question. Question looks very simple. Actually, we have to find out the shortest distance between the two lines. And actually, we have the parameter lambda in the first line. So given that the shortest distance between the two lines is 13 divided by root 29, and hence we have to find out the value of lambda here. So many students can think that this question is very easy because we have a very direct formula to find out the shortest distance and equate it to 13 divided by root 29. The main problem with this question is the two straight lines here are parallel because observe the DRs of this one, which is 2 comma 3 comma 4, and what about the DRs of this one, second line, 4 comma 6 comma 8, which are also same as 2 comma 3 comma 4 if we cancel out the common factor there. So as you can notice, the DRs are same or are in proportion exactly. So which means the two straight lines are going to be parallel. So even if you apply the formula for shortest distance, you're going to get 0, 0 divided by 0, which is not correct actually in this case. That is why we have to follow a small trick here. There is a derivation for the trick also. So you try the derivation. I will give you the small trick for this question and a very standard formula. Okay, I'll draw the diagram also. Let's keep it in mind. If this question comes again in the second main session, you have to do it in less than 1 minute if you know this trick. Okay. So let's take the two lines L1, which is x minus x1 divided by A1 is equals to y minus y1 divided by B1 is equals to z minus z1 divided by C1. Similarly, line L2 is x minus x2 divided by A2, y minus y2 divided by B2 is equals to z minus z2 divided by c2. Now, in this case, clearly you can notice that the two lines are parallel, right? So you can say that a1 b1 c1 a2 b2 c2 will have the same ratio, or else you can directly take it like this also, no problem. ABC, anything is fine, but make sure they are parallel. Now, the direct formula, that is the shortest distance between these two, is going to be determinant of I cap, j cap, k cap, x2 minus x1, y2 minus y1, z2 minus z1, and a, b, c, whole divided by determinant of I cap, j cap, k cap. So actually it is in the denominator modulus of square root of, and in the denominator it is directly square root of a square plus b square plus c square, and try to put a whole modulus to this one because in the numerator you're going to get a vector. Okay, so if you remember this formula, this question can be done in less than a minute. It's a short trick, and there is a proper derivation also for this one, like how we got this formula. So you try the derivation by yourself, and if possible, in any of the upcoming videos, I'll try to make the derivation of this one. Okay. Now let's try to apply this thing for this question here. So what are the two lines here? The two lines are given by x minus lambda divided by 2 is equals to y minus 4 divided by 3 is equals to z minus 3 divided by 4. And one more straight line is x minus 2 divided by 4 is equals to y minus 4 by 6 is equals to z minus 7 divided by 8. Okay. Now, just by looking at this formula, I'm going to apply. And moreover, in this question, already given that the shortest distance is what? 13 divided by square root of 29, which should be is equals to modulus of det of I cap, j cap, k cap. What is our second row here? X2 minus x1, right? So let's do x2 minus x1 here, which will give you 2 minus lambda, 4 minus 4, which is 0, and then 7 minus 3, which is 4. X2 minus x1, y2 minus y1, z2 minus z1. And then you can put ABC as any one of the TRs, it is fine. 2, 3, and 4. But whatever third row you are putting in the in the numerator, the same thing you have to take in the denominator as well. So it will be square root of 2 square plus 3 square plus 4 square. Okay. Now let us try to expand this one and try to simplify it so that we'll get a proper idea for this. So let's expand the determinant here. It will be modulus of I cap multiplied by 4, 0 minus 12, which is minus 12 I cap, and then plus minus j cap multiplied by, which will be 8 minus 4 lambda minus 8, and plus k cap multiplied by, which will be 6 minus of 3 lambda modulus whole divided by, this will be square root of, which is 16 plus 9, 25, 25 plus 4, root 29. So very clearly root 29 gets cancelled here. And finally what we have is 13 is equals to modulus of minus 12 I cap, and then this would be plus 4 lambda into j cap plus 6 minus 3 lambda into k cap. And then we know how to solve this one. Just expand this one, stand squared on both sides. You get 169 is equals to 144 plus 16 lambda square plus 6 minus 3 lambda whole square. Okay. And then you know how to solve the remaining part, right? So I will leave the solving part to you because it's a simple quadratic equation in terms of lambda. And if you solve properly, you will get lambda values as 1 comma 11 divided by 25, which means both are possible actually. For two values of lambda, this will satisfy. So because they are asking one of the value of lambda, whatever is in the option, you can mark it accordingly. Okay, as you can see, if you know this formula, it won't take much time to solve this question. Okay, so try to be very careful and concentrate on this. Okay, let's take the next question. And this is one of the easiest question that can be asked in JEE Main because it is also a standard IP question also. And let's see just the brief way to solve this question and in a very quick manner. Okay, so two equations are given which are satisfying by the directional cosines of two lines. So what the standard idea is, you will take one of the equation, that is 4l plus m minus n is equals to 0, and then you can write down here n is equals to 4l plus m, and then you just need to take this value of n and substitute in the second equation, so that I can write this as 2m into 4l plus m plus 10 into 4l plus m into L plus 3Lm is equals to 0. Okay. Now we know just how to expand this one, right? So what you're going to get is 8ml plus 2m square plus 16l square, sorry, plus 40l square, sorry, 10 times 4, which is 40l square, and then 10Lm plus 3Lm is equals to 0. So let's see what we get finally. We get the equation as 40l square plus 10 plus 3 plus 8, which will be 21 ml plus 2m square is equals to 0. Now, this is a simple quadratic equation, and quadratic actually, it's a simple equation which can be traced directly. So, it is 40 into 2, 80. So, 80 can be factorized as 16 into 5. Right? So, write this as 16 plus 5, and then properly factorize, you will get something like this 8l plus m multiplied by 5l plus 2m is equals to 0, which will give you two cases, right? So, let's take the case 1 here. Case 1 is 8l plus m is equals to 0 implies m is equals to minus 8l. And in the similar way, let's solve the second case also simultaneously. We get 5l plus 2m is equals to 0, or else I can say m is equals to minus 5l divided by. Okay. And then once we write this m value, you can take this m value and substitute back in the equation number 1 to get the relation between other two values. So if I substitute that, let's do that. N will be is equals to 4L and plus M. M is nothing but minus of 8L. So from there what you get is N is equals to minus 4L. Okay. And then similarly, in the second case also, let's solve simultaneously. Take this value of m and substitute it there. You get n is equals to 4l plus m, which is minus 5l divided by 2. And let's find out the n value from here, which is 8 minus of 5, 3l divided by. Okay. And then in the case 1, let's try to find out the ratio of l is to m is to n, because that will give you the drs, right? So it will be L is to, and what is the M value in the case 1? Minus 8L is to, N value is minus of 4L. If you cancel out the common factor here, we get the ratio as what? 1 is to, minus 8 is to, minus of 4. And the DRs can be directly taken as 1 comma, minus 8 comma, minus 4. Similarly, in the second one also, L is to M is to N is equals to L is to M value here we have got it as minus 5L by 2 is to N value is 3L divided by 2. You can cancel out the common factor L and multiply by 2 and you get the values is 2 comma, that is 2 is to minus 5 is to 3, which means you can take the DRs as 2 comma minus 5 comma 3. And you have the DRs of both the straight lines here, and you know very well now what to do when you have the DRs of two straight lines, and in the question they are asking us to find out the cosine of acute angle between them. So since you want acute angle, directly use the formula cos theta is equals to a1 a2 plus b1 b2 plus c1 c2 whole divided by square root of a1 square plus b1 square plus c1 square multiplied by square root of a2 square plus b2 square plus c2 square. Okay. And where this is a1, b1, c1, the first set of DRs, and take this as a2, b2, c2. Now you have both the values, both the set of values, take it and substitute it here, and from there you will get the value of cos theta. Okay. And if you solve properly, you will get the value of cos theta is 10 divided by 3 into square root of 38. Okay. I'm not saying this is a difficult one, but definitely these kind of questions can come in the next coming JEE main session. Okay, so try to be very careful with this. I hope this is clear. Let's take the last question for this video, and this was a interesting question from JEE Advanced 2020. And this kind of questions can come up in the JEE mains also, so you try to be very careful. It's a lengthy question, but we'll try to see the process and try to get the idea out of it. Okay. So two lines are given to you directly, L1 and also L2. And then there is a line L lies in the plane containing L1 and also L2. So indirectly they are saying that L1 and L2 are coplanar. And then this L also passes through the point of intersection of L1 and also L2. So which means you are supposed to find out the point of intersection of L1 and L2. And we know very well how to solve for the point of intersection. We have seen many questions from the previous video also, right? So what is your idea? Let's brief it. This is equals to k1. You will take it as k2, and you will write down the general point of on L1 and general point on L2 and equate the corresponding coordinates and then find the values of k1 and k2. And if you substitute back the values of k1, k2, you get the point of intersection of L1 and L2. Okay. And I'm leaving the solving part for you guys. Try it. Okay. So make sure you do it because it is a previous advanced question from 2020. So I'm writing the statement here. Solve for L1 and L2. Solve for point of intersection of L1 and L2. Point of intersection of L1 and L2. And if you solve it, you will get the point as some 1 comma 0 comma 1. Okay, I'm leaving the solving part to you. So if you solve it properly, you will get the point of intersection as 1 comma 0 comma 1. But if you observe carefully, line L is already given to you. Line L is x minus alpha divided by L is equals to y minus 1 divided by M is equals to z minus of gamma divided by minus 2. They are saying that this line L is passing through the point of intersection of L1 and L2, right? So what is the idea? If this, which means this 101 is a point lying on this line. Okay, so let's substitute and we'll get one condition from there. So what we get is 1 minus alpha divided by L is equals to 0 minus 1 divided by M is equals to 1 minus gamma divided by minus 2. So let's keep it as condition number 1 and we'll try to see the next part of the question. So now this is the more interesting, interesting part here. They said that the line L bisects the acute angle between the lines L1 and L2. So which means the line L is along the acute angle bisector of L1 and L2. So let us try to see a rough diagram for this one. So let us say this is line L1 and let us say this is the line L2 here, and moreover I'll try to write down the DRs also for this one. So by looking at the line L1 equation, DRs are 1 comma minus 1 comma 3 and the DRs of line L2 are minus 3 comma 1 comma 1. Okay. Now what I'll do is I'll try to do the dot product of these two vectors, because if the dot product is greater than 0, it is acute angle between them for this corresponding DRs, right? So it's like finding A1 A2 plus B1 B2 plus C1 C2. You can understand in that way. So I'm going to find A1, A2 plus B1, B2 plus C1, C2 for this corresponding set of DRs that are given here, which is minus 3 multiplied by 1 plus B1 into B2 means minus 1 into minus 1 plus C1 into C2 means 1 into 3, which will give you minus 3 plus 1 plus 3. So which is equals to 1, which means you can notice that this A1, A2 plus B1, B2 plus C1, C2 is greater than 0 for this set of dr. So which means if you take it in this way, you're going to get the acute angle between them. Now they are saying that this L is bisecting the acute angle between these two. So the diagram looks something like this here. Look at the diagram properly. Okay. Now, we have to recall the very important concept of DRs of acute angle bisector of two straight lines. Okay. So let's try to recall the property, very important one. If L1, M1, N1 and L2, M2, N2 are the DCs here. Be very careful, they are the DCs. DCs of two lines, capital L1 and capital L2. Then the DRs, again be very careful, here DRs, here DCs. L1, M1, N1, L2, M2, N2 are the DCs of two lines L1 and L2. Then the DRs of acute angle bisector can be taken as L1 plus L2, M1 plus M2, N1 plus N2. Okay, and this is a standard property, right? Even this property is there in the IP textbook also, intermediate IP textbook also, as a 2 marks question. And you can see the derivation also there for this one. Okay, now we are going to use this beautiful property for this question. But before that, let's try to convert this DRs into DCs, right? We know how to convert DRs into DCs. You simply divide by root over a square plus b square plus c square. So by looking at the first set of DRs, that is minus 3, minus 1 and 1, I'm going to write down the DCs here, which will be minus 3 divided by what is root over a square plus b square plus c square here, root 11, right? So minus 3 by root 11, minus 1 by root 11, comma, 1 divided by root 11. Similarly, by looking at the DRs of second line, 1 comma minus 1 comma 3, the DRs again will be 1 divided by root 11 comma minus 1 divided by root 11, comma, 3 divided by root 11 after dividing by square root of a square plus b square plus c square. Now we are going to find out the values of L1 plus L2, comma, M1 plus N2, comma, N1 plus N2. And these are nothing but L1, M1, N1, L2, M2, N2. And we are going to do that, from which we get minus 3 plus 1 divided by square root 11, minus 1 divided by square root 11, comma, 1 plus 3 divided by square root of. We just need to add both of them, obviously. And finally, what we get is minus 2 by root 11, comma, minus 2 by root 11, comma, 4 divided by square root of 11. And since these are the DRs, keep in mind, these are not the DCs of the angle bisector, these are the DRs of the angle bisector. And since they are the DRs, you can cancel out the common factor. And moreover, I'll cancel out the common factor minus 2 also here and make sure they are in the proper ratio, that is 1 comma 1 comma minus 2. And finally, the line L has the DRs as 1 comma 1 comma minus 2. Okay, so these are your DRs of the line L. Okay, I hope this is clear. But the question is not over yet, because here, if you observe carefully, the line L is already given to you. Okay, let me copy this. Line L is already given to you. And then let's compare with the DRs that we have obtained. Okay. So observe carefully. This is the given line already in the question, and these are the DRs we have got. And compare the denominators here. And just because you can see that the third coordinate is same for this DR, which means this first and second coordinates also must be same. Okay. And that is the reason I can write down L is equals to 1 directly and M is equals to 1 directly. Otherwise, you would have equated the ratios. Okay. And just because this third coordinate minus 2 is same in both of them, you can equate the remaining two coordinates also. If it is not same, what you would have done, directly take the ratios and equate them. Okay. And hence, finally, we have got the values of L comma M. And after getting L comma M, if we observe carefully, we have an equation condition number 1 to find out the other values, right? So let's take this and substitute it here. Now we'll take the value of L from here and M from here, and let's substitute it here. Finally, what we get is 1 minus alpha divided by 1 is equals to minus 1 divided by M is also 1 is equals to 1 minus gamma divided by minus 2. Equate these two. Directly what you get is 1 minus alpha is equals to minus 1, implies alpha will be is equals to 2. Similarly, equate these two here, you get 1 minus gamma is equals to 2. So gamma is equals to minus 1. So we have found all the values L, M, gamma, and also R. So look at the required part here. It's a multi-correct question actually. So they are asking everything in terms of L, M, alpha, and gamma. But since we found out, you know how to check the options here, right? As you can see, the question is definitely not a easy question or a question which can be solved in less than 1 or 2 minutes. Definitely, it needs lots of concepts. Okay. So once again, let's try to see what we have done. Very important model and a good question which has potential to be asked in JEE mains also by taking some part of it or some concept out of it. Okay. So what is the first thing? We have solved L1 and L2 and got the point of intersection. And since L is passing through this point of intersection, it has to satisfy that. So I substituted, I got condition number 1. And then they said that L is along the acute angle bisector of L1 and L2. So first I made sure that for this corresponding set of DRs, the angle between them is acute by finding out sigma A1, A2. Since it is positive, directly this will be the corresponding DRs of the lines. And then we have to use the beautiful property here, that is, whenever we know the DCs of two straight lines as L1, M1, N1, L2, M2, N2, to find out the DRs, keep in mind not DCs, DRs of the acute angle bisector of L1 and L2, you can directly use the formula L1 plus L2, comma, M1 plus M2, comma, N1 plus N2. And then we have successfully converted this DRs into DCs and used the property. And finally, we have got the DRs as 1, 1, minus 2. But in the question, already they have given you the straight line, And you can look at the denominators as L, M, and minus 2. Clearly, the Z coordinate is the same, which means X and Y coordinates also must be same. Otherwise, you can equate the ratios and get the values of L and M as 1, comma 1. And once we get these values of L, comma M, it's very easy question because already we have condition number 1 from the solution here. Substitute that to get the values of alpha, comma gamma. Okay, I hope it is clear. And then if it was obtuse angle bisector, you would have written the formula as L1 minus L, M1 minus M2, N1 minus N2. Okay, so these are the 5 questions which have a good potential to be asked in the upcoming JEE main session. So try to concentrate here and try to go through all the questions. Okay, so we'll try to see the next part later. Okay, thank you.